This section is on line segments, and so you have a note sheet that looks like this. We have some warm-up questions that you could certainly answer. But to get started with the lesson, we want to talk about what line segments are and how to calculate the measures or lengths of line segments and what it means to be congruent. So first of all, we need to understand that a line segment is something that can be measured. So we can use a ruler or some other measuring device to figure out how long a line segment is. And it consists of 2 points. Those points are called the endpoints, and it's also all the points that are in between them. The 2 endpoints are used to name the segment. So if this first segment that is probably quite obvious is segment AB, but we could also talk about this portion of the segment, segment AC, or this portion of the segment CB or BC. So we first of all need to understand what the concept of betweenness of points is. And if we say that point C is between points A and B, that means that we're talking about a segment and A, B, and C are collinear, they're all on that same line, and the distance between points A and C plus the distance between points C and B is equal to the distance between points A and B. So when we see AC with no symbol on top, AC, no line on top, no segment symbol on top, and we haven't introduced that segment symbol yet. If it's just plain old AC, that means it's the distance between points A and C, which is a lot harder to write than just a capital A, capital C. So our first example is going to be to find the measurement of, or the measure of segment XZ. So from X to Z, X is an endpoint, Z is an endpoint, and Y is between those 2 points. And so if we want to find the distance between X and Z, this total distance between these 2 points has to be the sum of the distance between X, Y, and the distance between Y and Z. Because remember, points have no thickness, no dimension. And so if we add the 11 and 3/10 centimeters with the 3 and 8/10 centimeters, we are going to get 15 and 1/10 centimeters. That is the distance between X and Z. We can also do the same with fractions. If we want the measure of segment DF, or the distance between points D and F, then we're going to add the distance between points D and E and the distance between points E and F. And so we can add 2 and 7/10 with 5 and 9/10 and get 7 and 16/10. But 16/10 is the same as 1 and 6/10. So we have 8 and 6/10, or 8 and 3/5, which is equivalent to 8 and 6/10 as a decimal. So it's your choice. I don't care if you give me an answer in fraction form or in decimal form. They're the same thing. All right. So second example. Well, what if I need to find the measure of segment QR, or I want to know what is the distance between points Q and R? And they give me a measure. We draw 2 lines or 2 segments and span it, and we say 13 and 3/4 is the whole distance between P and R. Well, PR, the distance between P and R, minus the distance between P and Q, should be the distance between Q and R. So instead of adding, this time we're subtracting. So 13 and 3/4 minus 6 and 5/8 means I'm taking 13 minus 6 and getting 7, and then I need to take 3/4 minus 5/8. But 3/4 is the same thing as how many eighths? 6/8. So I've got 6/8 minus 5/8, which gives me 1/8. And again, you can use your calculator to find this. If you know how to use those fraction buttons, the distance between points to Q and R is 7 1/8. All right, so then we sometimes need to be able to write and solve equations to find measures. So in this example, we ask you to find the value of x and the distance between B and C. So we've got two things here. We need to find out what x is, and we don't want to stop short and not finish, but we want the distance between B and C as well. If point B is between points A and C. So first let's draw any old segment. Doesn't have to be accurate, but it does need to be a straight segment. And if B is between A and C, B is somewhere in here between A and C. So maybe I'm putting point B here. Then they said the distance between A and C is, this whole distance between these 2 points is 4x minus 12. And the distance between A and B is x, and the distance between B and C is 2x plus 3. Well, now that we have a visual of it and we've placed things in the proper spots, we can see that if we added the distance between A and B to the distance between B and C, because B is in between these two, we see B in between them, those two together should add up to the distance between points A and C. So if I add x to 2x plus 3, I should get the 4x minus 12. So when we have x and 2x on the same side of the equation, we do eventually want to get x by itself, but these two are like terms, x plus 2x, 1x plus 2x is a total of 3x. So we're combining our like terms, 3x plus 3 is the same as 4x minus 12. And now x's to one side, numbers to the other. I'm going to make a zero pair here. I'm subtracting 3x from both sides. Could also have subtracted 4x from both sides. 3x minus 3x is nothing, and 4x minus 3x is an x. So I'm keeping my equal sign where it was. I had a positive 3 on the left side. I have a negative 12 on the right side. And now to get the numbers to the other side, the opposite of a negative 12 is a positive 12, so I'll get a zero pair if I add 12 to this side, but whatever I do to the right, I have to do to the left. This gets me a 0, and I'm left with an x on the right side, and I get a 15 on the left. And that, in algebra, is enough. But we asked you to find two things. We want to know what's x, so we're going to box it or circle it. We know what x is. But now we want to find the distance between B and C. Points B and C stands for 2x plus 3. So if BC, the distance between these 2 points, is 2x plus 3, how do I find out what that distance is? Well, we said before that x is equal to 15. So if I substitute or plug 15 in for x, I'm taking 2 times 15 and adding 3 to it. 2 times 15 is 30. 30 plus 3 is 33. So the distance between B and C is 33. And now we've answered both pieces of the question. All right, we've got an example 4 here, and it talks about the betweenness of points. Daryl is visiting the Space Center in Seattle, Washington, and he knows the height of the Space Needle. The whole thing is 605 feet. So from the very, very top all the way to the ground is 605. And the distance from the ground to the observation deck, oh, here's the observation deck. And so from the ground to the observation deck is 10 feet more than 6 times the distance from the observation deck to the top. Okay, 10 feet more than 6 times the distance. We don't know what this distance is from the observation deck to the ground, and we don't know what the distance is from the observation deck to the very top. But if we're taking 10 more than 6 times something, let's let this value be the x or the variable in it. And this is 10 more than 6 times x. Well, 6 times x is 6x. If I need 10 more than that, I'm going to add 10 to it. And now we have something similar to what we had a moment ago when we had that segment with this point that was in between, and the whole distance is 605. So from here to here is 605. But from the ground to the observation deck is 6x plus 10. And the observation deck to the very top is x. So our equation now is going to say 6x plus 10 plus x more has to add up to the 605. Once again, we have some like terms. 6x plus 1x are on the same side of the equation. That gets us 7x. 7x plus 10 equals 605. And then as we prepare to solve, we need to get letters to one side, the variables to one side, and the numbers to the other. And so if we want to keep our 7x where it's at, then we're going to subtract 10, because a positive 10 and a negative 10 get us a zero pair. And so 7x plus 10 minus 10 are gone, that's a 0, is equal to 605 minus 10 is 595. And then if I want to find the value of x, I'm going to divide by 7. And x will be equal to, let's see, 59 divided by 7, 73 would be 9, so 8 times. Blanking out here for a moment. So 85 is our value of x. All right, so next we need to talk about line segment congruence. So if two geometric figures have exactly the same size and shape, we call them congruent. They don't have to be in exactly the same position. They can be oriented differently. And so when two segments have the same measure, they are considered congruent segments. So congruent means the same, having the same measure. And there's a symbol for congruent. So this is the symbol for congruent. It looks like an equal sign with a tilde on top. And when we say that segment AB is congruent to segment CD, that means the distance between A and B is equal to the distance between C and D. Those two values are the same. So 1.7 centimeters is the same as 1.7 centimeters. Since 1.7 equals 1.7, that means the two segments are congruent. And we can denote that by showing a little dash, a little red dash on those segments. Those tick marks show that those have the same measures. So when we're trying to work this problem out and it says find the value of x if Q is between P and R, okay, Q is between P and R, but this time they told us that segment PQ and segment QR are congruent to each other. That means they've put these two red tick marks to show that they have the same length or the same measure, and that means that we can make 6x plus 20 be equal to 2 times x plus 6. And now we're going to practice a little algebra skills again. When we see that we have 6x plus 20 is equal to a 2 with a parentheses, that means that we're going to distribute that 2 to both of the x and the 6. So 2 times x is 2x, 2 times 6 is 12. And then we want to get letters to one side, numbers to the other. The variables can go to the left if we prefer, so we're subtracting 2x from both sides. And 2x minus 2x is gone. The equal to stays where it's at, and 6x minus 2x is 4x. So that zero pair helps us. And then we're bringing our 12 down in order to keep the 4x by itself. It has a positive 20. 20 is added to it. The opposite of adding is subtracting. So we're doing opposite operations here. Positive 20 and negative 20 gives us a zero pair again, and 4x is equal to a negative 8. Oh, that seems scary. If I divide by 4, because 4 times x is equal to -8, I have to do the opposite of multiplying, which is dividing. 4 divided by 4 is 1. 1x is equal to a -2. And so it says to find the value of x, and we said that's -2. All right, well, that seems kind of strange. X is -2. Well, that caused a problem. Well, if I plug a -2 in to check this, 6 times a -2 is going to be a -12, and a -12 plus 20 gets me 8. And -2 plus 6 is going to be a +4. 4 times 2 is also 8. 8 equals 8. It worked. All right, so there's exit ticket for you to work out. And then your assignment.